Introductory Neuroscience and Neuroinstrumentation Demo Wireless EEG with Dry Electrodes. In this demo, I will be assisted by Hema Hariharan, who's teaching assistant on this course. So hello and welcome to a demo of 8-channel EEG recordings with the EEG cap and dry electrodes. The contents of this demo will include stimulation, auditory tones at a frequency of 1 Hz, EEG cap, dry electrodes and a signal conditioning unit, free running EEG and delta, theta, alpha and gamma bands, and the auditory evoked potential. Okay. So here we have an 8-channel EEG electrode which has been put on the subject's head. You can see the EEG recordings happening, and on the side over here you have 8 green channels which shows 8 electrodes. The impedances are very good. Hema will be telling you about the impedances when she talks. And we have set the scale at 200 microvolts, and this is just free running EEG. What we are using is Inobio 8, which is a dry channel system. This is the Inobio 8 system, and it has got 8 channels, and we have a ear clip which we have attached to Hema's right here, and the ear clip has 2 electrodes. One electrode is the reference and the other electrode is the ground. So that is over here. Okay. And the electrodes we are using are these comb electrodes or dry electrodes. You can see each electrode has a prong on it, 10 prongs, and even if one prong touches the scalp, we get good recordings. As you can see, it's all green on the impedances, right? And this leads to an impedance, this leads to an NIC conditioning unit, signal conditioning unit, and the signal conditioning unit has a preamplifier, filters, amplifier, a notch filter, and a Wi-Fi module by which it transmits the signals to the laptop. Okay, and in case you use wet electrodes, then we have electrodes which are like this, and we use this gel. We use a syringe to insert the gel into the electrodes, and then we can get recordings. This is a little uncomfortable for the subject because you get all this conductive gel goop on your head which you have to wash off. Okay, right. So now coming back to the EEG, we will show some maneuvers. So first of all, this is free running EEG, and it is surprising that we are getting such good recordings in a studio full of electronic equipment. So normally you will have a lot of AC and contamination in the signal. So free running EEG will increase the scale so that this is the usual scale, 100 microvolts per division. So now this is the default EEG. So let's look at just the delta band. So we can visualize the delta band. I press the button over here, and the delta band, if you remember, is 0 to 4 Hertz, and it's slow waves, and usually it's prominent when you're sleeping. Here we are filtering the EEG. The EEG has all the bands, so we are filtering it, and we are just looking at the delta band. The big jerks up and down, that is because Hema is blinking or she's moving her eyes. So this is the delta band. So now we look at the theta band. Okay, so theta band is from 4 Hertz to 8 Hertz. Okay, and this you have in the scalp recordings when the person is kind of drowsy a little bit. Okay, and now we look at alpha band, and alpha band is between 8 to about 11 Hertz. And Hema, if you could, when I tell you, if you could just close your eyes now. So you see the bursts happening over here. So these are alpha bursts. So this happens when a person is relaxing or meditating. So you can open your eyes. So it becomes less. And then you have the beta band. This is the normal, band which you record, which predominates in normal EEG, and this is between 12 to about 20 Hertz. Okay, and then finally you have the gamma band, which is above 30, and these are high frequency bursts, and I can increase the magnification so that So these are very small amplitude, high frequency things, so you can barely see it. Let me change it even further. Yeah. So these are the gamma bursts, which you get from EEG. Cool. Okay. So we shall get back to the normal, 100, 200, and we're looking at defaults. So now we will show some manipulations. What are the different artifacts you get? So I will go through a few artifacts, and these are things which contaminate the EEG, and you have to be very careful to remove them when you're doing the analysis. So Hema, could you please blink? Okay, so this is the eye blink artifact. Okay, stop. So Hema, could you please clench your teeth? So you see this stuff over here. So this is EMG activity. She's also blinking, but you also get this EMG activity over here. And this is high frequency activity, can be mistaken for beta or gamma. So we have to be very careful to take these artifacts out. Can you clench your teeth again? Yeah. So all these are EMG activity. Okay, stop. Now another artifact where the eyes actually, if you look at the structure of the eye, in front of the lens is the aqueous humor. Behind the lens is the vitreous humor, and they have differing ionic compositions. So when you move your eyes, there's a dipole, and that causes artifacts. So and it's made worse by the fact that both the eyes move, together. It's called conjugate movements. So Emma, can you move your eyes? Yeah. Can you stop? Can you move your eyes, please? Yeah. So these are the ocular dipoles moving. Okay. Stop. Can you please blink? Yeah. They are kind of similar in amplitude, but different compared to the ocular dipoles. Can you clench your teeth, please? Just to reiterate, these are the EMG thing artifacts. So all these artifacts can generally be removed very simply if you just set your window, your amplitude window to plus minus 100 microvolts, and run this window through your raw EEG recordings, and that will take off most of the artifacts. There are different algorithms which are used to take out artifacts, but the simplest one is moving amplitude window. Okay. So we have the presentation software on the left panel, which is giving auditory stimuli. This is an auditory evoked potential experiment. We have free running EEG being collected from the subject set, 8 channels, and we shall start. And this is a 1000 yeah. So this is a stimulus at 1000 hertz. It's being given at a frequency of 1 hertz, and we usually use an average of 100. So we give 120 stimuli in case we have some problems with artifacts. We have to throw them out. So even if we throw out 20, we still have 100. So you see the stimuli being given over here, and it's not so that's basically it, and I shall stop it now. Okay, so at the end of the stimulus, you have a log of the different stimuli which were given. What were the triggers? Because you need to average them according to their triggers, and the interstimulus interval if there's a response, and so on and so forth. So you have a log file at the end of it. Okay. All right. And now. So here, this is an Mmn experiment where every 5 stimuli we have a slightly different tone. So there are 3 different tones. It's a delta Mmn. So the first, the standard stimulus is at 1000 hertz, and the 3 stimuli are different deltas. So first you have a delta of 10, then you have a delta of 100, and then you have a delta of 2000. The reason we chose this is that in physiology, usually a power function is involved. So we're looking at a delta of 10, 100, and 1000. The actual stimuli are 1000 for the standard, 1010 hertz for the first deviant, the second deviant is 1100 hertz, and the third deviant is 2000 hertz. Now the stimuli of each of these are different. We have coded them differently, 1, 2, 3 and 4, so that we can average them separately and subtract them for the Mmn response. Yeah. And now these are the log of the experiment we did so far. If you look at the code, you see different stimuli triggers. These are the standards. Then you have a deviant over here. Then you have standards, another deviant over here, standards, another deviant over here, and so on and so forth. So these deviants are given randomized in a randomized fashion, so that we are actually looking at the brain response through different Mmn stimuli in these experiments. Thank you.